Hello guys, welcome back to the QST channel. Okay, let's start. The magnitude of the linear momentum. Okay, so momentum is it's P, it's equal to mv. So 0.009 times 380. Exactly, it's 3.42. I can put that or 3.4. Okay, this is memorization. So first, the skydiver jumps from the plane without opening his parachute. So he goes really fast until he reaches terminal velocity. Then he opens his parachute and he slows down until he reaches terminal velocity again. Okay, for this one, you can do the slope or you can do Hooke's law, which is F equals K delta H. I mean delta X. Sorry, delta delta X. So you choose any point on the graph. 1 equals K 0.02 times. Okay. So you divide 1 divided by 0.02. It will give you 50. Okay, part A, it's memorization. So total momentum before collision is equal to total momentum after collision. Okay, for this use a rule MAUA plus MPUB equals to MAVA plus MBVB. Okay, the mass of a gun is 0.5 kilograms and the mass of the bullet is 0.009. The bullet is fired leaving the muzzle at a speed of 300. Okay, first of all, before the bullet is fired, the gun and the bullet are stationary, so they're not moving. They don't have a velocity. So here the initial velocity is 0, and here it's 0. 0 times the mass, it will be 0, and here also the 0 times the mass will be 0. So this whole part of the equation is 0. Now the other part, you actually solve it. So 0.5 for the gun times times the velocity we're trying to find it plus 0.09009 sorry times 300. 0.009 times 300 is 2.7. Okay, so 0.5v plus 2.7. Move it to the other side. 0.5v equals to negative 2.7. You will get that the velocity is negative 5.4, but here they said the speed is never negative, so you put it as 5.4 only. Okay, for this use the same rule. A ball mass 0.2, so 0.2 times 5 the initial velocity. Collides with a stationary ball. Stationary means the velocity is 0, so this whole thing is 0 here, equals to the new, okay, so 0.2 again, they stick together and move together, so they have the same velocity. So 0.2 v, let's call it v, plus 0.3 v. Okay, so 0.2 times 5 equals to 0.5 v. 1 equals to 0.5 v, so v equals to 1 divided by 0.5 is 2 meter per second. The impulse, there's two rules for impulse. It's delta p. Okay, delta p equals to f times t, or delta p equals m delta v. Okay, here they give us just force and time, so we use this one. So 500 times 0.160 will give you 80. Okay, a ball of mass 200 grams collides with the ground at a speed of 3 meters per second. Right after it bounces back, its speed is 2.5. Okay, they want the impulse. Here they didn't give us a force. They give us mass and velocity. So we're gonna use delta p equals m delta v. Here you can write delta v as delta p equals to m v final minus v initial, right? Here the final velocity, it's not 2.5, it's negative 2.5. See, if I'll draw it, okay? The ball, look, it's going down 3, okay? Let's say the positive direction is going down. So if it goes back up, it will be negative 2.5 because it will oppose the motion of direction. Okay? So delta P equals to, the mass is 200, but we do 200 divided by 1000 because we need it in kilograms. So 200 divided by 1000 is 0.2 bracket. V final is negative 2.5 minus initial velocity is 3. So negative 2.5 minus 3 is negative 5.5. You will get it, to be negative 1.1. But you don't need to say that's negative because they just said magnitude. So it's 1.1. Okay, this memorization. The measure of the turning effective force is called the torque or the moment. Okay, this also memorization, but you can derive it from the formulas of momentum. P equals, actually I don't need to explain this. How you memorize it? When two or more objects interact and no external force acting on them, their total momentum remains constant. Yes. Okay, this is the rule I wrote. Okay. An object of mass m is moving with a constant velocity v along a straight horizontal road. The object is exposed to a constant force F opposing its direction for 5 seconds. The magnitude of the force is 100 newtons. What is the change in the object's momentum? Okay, so you know that the impulse is delta p and p is momentum, right? So it's the change in momentum, right? And here this is change. Delta means change, right? So delta p equals to F times t. Here they gave us force and time, so 100 times 5 equals to 500. But they said opposing its direction, so it's actually negative 100, sorry. So it's negative 500. When two objects collide, they exert on each other equal and opposite forces. The law of conservation of momentum gives us the evidence we need to arrive to Newton's third law. Yes, you memorize this. Okay, a student is making a spring balance using a spring with an arrow and ordinary ruler. She wants the existing marks on the ruler to correspond to the force applied to the spring balance in newtons. The ruler is originally graduated in centimeters. So basically, she wants 1 newton per centimeter, right? But here they ask they want it in meters. So 1 newton over, how to convert centimeter to meter? Divide by 100, right? So it will be 0.01 meter. So you simplify this, 1 over 0.01 is 100, so 100 newton per meter. Okay, the two particles A and B of respective masses 60 and 40 grams are moving towards each other, each with a speed of 5 meters per second. Upon collision, they stick together. Their speed will come one. Uh, actually, okay, they want the speed and the direction. So they said stick together. So that means what that means is um, they will have the same final velocity. Okay, so ma is what? Okay, first you convert all of this into uh, kilograms. It will be 0.06 kilograms and 0.04. So 0.06 times 5 plus 0.04 times, they said both of them with a speed of 5. So wait, A is going like this 5 and B is going like this also 5. But one of them is moving in the positive direction, one of them is 5, one of them is negative 5. You can choose each one. I mean, you can choose which one you want to be negative, but I chose B to be negative, so negative 5 equals to 0.06 velocity plus 0.04 velocity also. Okay, now simplify this. 0.06 times 5 is 0.3 and 0.04 times negative 5 is negative 0.2. So minus 0.2, this side will be 0.1. Add these together, it will become 0.1 V. So V is equal to 1. It's positive, and we chose that A is positive, so it's the direction of A. If we chose B to be positive, then if it's positive, then it's B. Okay, a firework moving at 2 meters per second to the right explodes and breaks into two equal fragments. One of the fragments travels to the left at 10 meters per second. Okay, two equal fragments means they have the same mass. Okay, so instead of ma, mb is just m. Okay, so they had the same velocity at the beginning because they were part of the firework, right? 2m plus 2m equals to 10m plus the other one, the other fragment, I don't know, we're trying to find it, vm. Okay, so 4m equals to 10m plus vm. Oh, sorry, this one is negative 10 because it said travels to the left and it starts from the right. Okay, so it's negative 10m. So you add the 10 to this side, it will be 14m equals to vm. Cancel the m, v is 14. So it's positive, like so it's to the right. Because we chose the right to be positive, we made the left negative. Okay, this one is past stuff. What's the term used to represent the speed that the skydiver reached? Terminal velocity. Yes, you memorize this. Okay, and then when he's at terminal velocity, the net force is always 0. The magnitude of air resistance is equal to the weight. So you just find the weight using W equals mg. Mg is 60 times 10 equals 600. Okay, for this you use Hooke's law. F equals k delta x. David has a spring of unstretched length 5. When he hangs a weight of 20 newtons from one end of the spring, length becomes 15. So you have the force 20 equals to k. For delta x, you do the initial the final length minus initial length. So 15 minus 5, you will get 10 centimeters. To convert the centimeters, you divide by 100. So 10 over 100 will be 0.1. So k times 0.1 divided by 0.1, you'll get k equals to 100. Let's memorize it. Strength, you need the force to break them, it is a large force. Elasticity, it will come back to its original shape. Ductility, made into wires. Stiffness, it does not stretch or bend. Brittle, it will break suddenly. Plasticity, it will stay deformed. Okay, for this one, they give you what? A two. Okay, wait. Let me just read it. A 2 kilogram trolley is subjected to a constant horizontal force of magnitude 10 newtons for 3 seconds. The trolley is initially at rest, then its final velocity after 3 seconds is 15 meter. Okay, why am I reading this? Okay, so you have force and time. So you can use delta P equals to F times T, which is 10 times 3 equals to 30. You have another rule which actually has velocity, what we want to find. Delta P equals to M delta V. Now you have delta P and you have the mass. So we substitute it in here to find delta V. So 30 equals to 2 delta V. Delta V equals 15. Delta V is what? It's final V final minus V initial, right? Equals 15. V initial is 0. So it's just V final equals 15. So that's the answer. A rotating bicycle wheel pushes the earth backward. So it's opposite. So the earth pushes the bicycle wheel forward, and then the human pushes the ground. So the ground pushes the human upward, not backward. Boat pushes water down. So the water pushes the boat up, and then the rocket pushes the gas down, and the gas pushes the rocket up. Okay, guys, thank you. Hope you enjoyed. Bye bye.